Welcome back to our lesson practice review, where today we're going to be going through Chapter 2, Lesson 7 practice. To kind of go over our lesson summary here, we really are introducing or reintroducing the idea of what we call complex numbers, where we have this format of a plus bi, where we have a and b, which are real numbers, and I represents the imaginary unit, or the fact that we were square rooting a negative number. So a couple of examples here. Two things that we're going to go through is really once we get to this step right here, we add the 4 to both sides, we take the square root, and then when we're square rooting the negative, that's where we get that I in our answer. The second version here is still completing the square like we've done before. It's just doing it a little bit differently in the sense that instead of looking at just this and seeing what we need, because we can see like, okay, half of -6 is -3, and then we square that, which becomes 9. Instead of adding 9 to this, we already have this plus 12. And so what we're doing is we're subtracting 3 from both sides of the equation so that we get that 9 that we're looking for, so that we can then factor it into x minus 3 squared. And so it's still completing the square. It's just one kind of step different than we're maybe used to. But we're still looking at that b value or this number here and looking at what is half of it and what is that squared. Because half of this or this we square root both sides, and then when we get that square root of a negative number, we get I. And again, represent the I here, but that doesn't necessarily take away the square root. And this first one here, when we did the square root of -16, the square root of the -1 and the square root of 16, this became 4, and this became I, which is why we have 4I. Whereas when we did the square root of -3, we have the square root of -1, which becomes I, and the square root of 3, which stays the square root of 3, because we can't simplify it. All right, for number 1, which of the following describes the solutions to x minus 3 squared equals -25? And in this one here, I would say that there are two non-real solutions, because the next step in this problem would be to square root both sides. And when I square root that negative, I end up getting the square root of -1 in there, which becomes I, or represents our imaginary solutions. For number 2, Sydney made a mistake while solving x squared plus 8x plus 10 equals -15. So to kind of check here where the mistake was, again, we're using this idea that, okay, half of this is 4, and 4 squared ends up becoming 16, which is what we're looking for. So Sydney added 6, but the issue is that we can't just add 6 to the equation. If we're going to add 6 to one side of the equation, we also have to add 6 to the other side of the equation. So B here says determine the correct solution. So once we get to this step here, I'm going to just rewrite this step as x squared plus 8x plus 16, and then -15 plus 6 would just be -9. I factor this using my identity here to get x plus 4 squared equals -9. I take the square root of both sides, which gives me two answers. X plus 4 equals plus or minus the square root of -9, which I'm going to represent as the square root of -1 and the square root of 9, which then becomes 3 and this becomes I. So x plus 4 equals plus or minus 3I. Sorry, I'm running out of space here. And then subtracting 4 from both sides gives me 4 plus or minus 3I. And if we want to write that out as our two different answers here, we get x equals 4 plus 3I, and our second answer here 4 minus 3I. So for problems 3 through 5, solve each equation. Use I to express non-real solutions. Show or explain your thinking. So for number 2, the first thing we're going to do here is divide both sides by 2, which gives me x plus 3 squared equals -16. Then I take the square root of both sides, which gives me x plus 3 equals the square root, plus or minus the square root of -16. And now this is the last time I'm going to do this. I'm going to split this up to show that that's -1 times the square root of 16, which this becomes I and this becomes 4. So we get x plus 3 equals plus or minus 4I. subtract 3 from both sides, and I'm just going to leave my answers, two of them like this, -3 plus or minus 4i. For number 4, I'm going to, first of all, let's take a look here. A couple different ways to do this one. I am going to use what I know about completing the square. Half of this is -5, and -5 squared becomes 25. So I'm actually going to be adding 25 to both sides. So what that becomes is x squared minus 10x plus 25 equals -7 plus 25. And then I factor this, which becomes x minus 5 squared, and simplify this, which becomes, what is that? 18, positive 18. Take the square root of both sides, which gives me x minus 5 equals plus or minus the square root of 18. The square root of 18 can be simplified here into, I know that 18 is 9 times 2, and the square root of 9 is 3. So x minus 5 equals plus or minus 3 root 2. And then I add 5 to both sides to get 5 plus or minus 3 root 2. Number 5, let's hope I have enough room for this one here. So in this one here, same idea. I'm going to kind of use completing the square here. Half of -8 is -4. -4 squared is 16. So what I need to do here is I need to subtract 10 from both sides, because then what that makes it is x squared minus 8x plus 16 equals -7. Then when I factor this, it becomes x minus 4 squared. And then I take the square root of both sides, which gives me x minus 4 equals plus or minus the square root of -7, which then I can rewrite as plus or minus I root 7, because that's square root of a negative. And then I add 4 to both sides to get 4 plus or minus I root 7. Number 6, in the equation -2 times x minus 3 squared plus 4 equals p. P is a constant. What is the largest value of p that could result in only real solutions? So to start explaining this one, I'm actually just going to kind of plug in a number for p to see what ends up happening here. I'll start with just kind of plugging in 0 to see what happens, and we'll see if we get, real solutions or non-real solutions. And when I do this, I subtract 4 from both sides, and then I'm going to divide by -2. And when I divide by -2, I get a positive value over here, because after I square root this, that's what tells me, am I going to get real or non-real solutions? So this right number here has to be a positive value. And since I'm dividing by a negative here, I know that when I subtract 4, I need it to also be negative. So for example, if I were to plug in just 4 in for p, let's do that over here. We got -2 x minus 3 squared plus 4 equals 4. So when I subtract 4 from both sides here, I end up getting 0, which would give me a single solution, because when I divide by -2, I get 0. And then when I square root, I just get x minus 3 equals 0. So that would give me one solution. And so basically, if I made it anything larger than 4, like for example, if I plugged in 5 here, I'd subtract 4 to get 1, and then divide by -2, which now gives me a negative number. So when I take the square root, I now get non-real solutions. So the p-value, the largest p-value that would only give me real solutions, would have to be p equals 4. That's the highest value. Because if I go higher than that, like 5, you see that we end up taking the square root of a negative. So for number 7, it's really looking at order of operations here. So PEMDAS here, I'm going to be doing kind of everything underneath this square root first before I square root it. Then exponents here, 8 squared is 64, minus 2 times 3 times 7. Now I have to do multiplication from left to right. So 2 times 3 is 6, and then 6 times 7 is 42. And then 64 minus 42 is just 22. So my answer here is just the square root of 22. Number 8, I'm going to be doing the same thing here. Negative 2 squared is 4, positive 4. Then I have to do multiplication from left to right. So 4 minus 4 times 3 is 12. 12 times negative 1 is negative 12. This is all in a square root. And then when we subtract a negative, it makes both of these positive. So 4 plus 12 ends up becoming the square root of 16, which the square root of 16 is just 4. For number 9, all right, so again, our parentheses here, this P for PEMDAS, is really going to be what we use for the square root here. So I'm going to deal with that first. 4 squared is 16. 16 plus 9 is 25. Square root of 25 is just 5. And then I end up getting 8 over 15, which we can put in our boxes here. And last one here, the square root of 12. Okay, so this is a little bit tricky. The square root of 12 can be simplified, right? So if I do that down here, this breaks down into the square root of 4 times the square root of 3. And the square root of 4 is just 2. So what I end up getting is 4 plus 2 root 3 over 8. And now here's where it gets kind of tricky, is that if you look at like kind of what our final solution is here, that 2 goes away. So really what I'm going to do here, the way I'm going to word this, is I'm going to take the greatest common factor of the top. Since there's 2 terms, let's do this, 4 and 2 root 3. When I take out the greatest common factor of 2, it's like pulling that out, and we divide each term by that. Because again, just to show you, like if I were to distribute that 2 back into it here, I'm going to erase this in a second, but it would end up giving me 4 plus 2 root 3, which is where we started. So I'm just doing the opposite of the distributive property here. The reason I'm doing that is now, since this is multiplication, I can kind of simplify this 2 over 8. So what that means is that 2 over 8 simplifies to 1 over 4, which then gives me 2 plus root 3 over 4, which is now what I can plug in into my final answer here of 2 plus root 3 over 4. That about wraps up our Chapter 2, Lesson 7 practice. Next up will be Lesson 8, where we continue talking about quadratics.